Hey everyone, this is Ryan DeGregorio, one of Wyoming Stargazing's program leaders. Thanks for joining me and welcome to Mind Bending Astronomy. In every episode, we'll share with you a mind-bending fact about astronomy. Last time we talked about what it would be like to fall into a black hole. Today, we're going to also talk about black holes, but something far more mysterious than just falling into it. We're going to talk about something called Hawking radiation. And to be honest, this may be the most mind-bending episode because we're going to combine the effects of quantum mechanics with those of general relativity. Now, according to quantum mechanics, and this is already going to sound quite bizarre, but empty space isn't completely empty. Inside empty space, or just the vacuum of the universe, things called virtual particles randomly appear and then annihilate. And what's happening here is out of nothing, virtual particles come into existence, a pair, one of antimatter and one of normal matter, and they crash into each other and vanish. That's it. And this happens pretty frequently in outer space. Now, what happens when these virtual particles just pop into existence near the event horizon of a black hole? Well, something quite strange happens. If the pair forms near the event horizon, one of the partners may fall into the black hole while the other is free to escape. Now, let's backtrack a little bit and how these virtual particles came into existence in the first place. It sounds bizarre because energy cannot be created nor can be destroyed. What is really going on is these virtual particles are essentially borrowing the energy of the still flat universe, and then they return it when they collide back into one another. When one of these partners falls into the black hole, it borrows energy from space itself and it dives into the black hole, and the other one is free to leave. But the particle carries with it, and here's another strange thing about quantum mechanics, that particle creates a negative energy. And so the black hole essentially is leaking this radiation. Now, a couple things to keep in mind. Nothing can escape the event horizon of a black hole, and that's fine. Nothing is leaving the black hole. Nothing that passed over the event horizon is coming back out. The other thing is, yes, black holes do accrue matter over time, but the reason Hawking radiation came into existence, the reason it's a theory in the first place, is black holes don't seem to just gain mass forever. They can't. Otherwise, we'd have a lot of problems. But instead, when the black hole has this negative energy, when it's amassing this negative energy, they will eventually evaporate. And these time scales are far, far greater than the lifetime of the universe. So the universe, as we know it, has been around for about 14 billion years. That's 1.4 times 10 to the 10 years. When the last black hole evaporates, we're talking on the order of 10 to the 100 years, or even longer. And that's Hawking radiation. And there are plenty of other bizarre consequences of quantum mechanics. But this is what happens when you mix those with a black hole. Join us next week for another mind-bending episode.